and welcome. My name is Tamara Hambrick from Northrup Grumman Aerospace Systems Sector. I'm currently the Director of Systems Engineering, Electronics and Payloads at our Palmdale Aircraft Integration Center. I wanted to talk to you a little bit about how I got here in Model-Based Systems Engineering. Previous role I had in 2018 was the Model-Based Systems Engineering Chief Architect on a program called H1LTI. I was residing in Mission Systems Sector at the time with a team of MBSE experts that were executing across proposals, programs, and supporting multiple sectors in executing this methodology. I was reached out by Woodland Hills, California for this program, H1LTI, to bring forth our knowledge, our guidebooks, our training, as well as how we've been executing it on programs for the last decade to help bring the awareness of how they could execute onto this program and be successful. At that point is when I first met Jason Forth, and understanding that our relationship and partnership to make this program a success was a fruitful relationship, and it continues to grow to this day.
Thank you, Tamara. As Tamara mentioned, my name is Jason Forth, and I work here at the Naval Air Station Patuxent River. I'm currently assigned to the Naval Air Warfare Center Aircraft Division, and part of my assignment there is through the Systems Engineering Transformation Initiative here at NavAir. Within that assignment, I'm assigned as a pilot lead to various programs across the command to help them infuse model-based systems engineering and digital engineering techniques as we look to migrate into the future. The presentation you're about to see was given by Mrs. Hambrick and I at the 21st Annual NDIA Systems Engineering Conference back in October 2018.
So let me give you a quick overview on H1 Lead Technology Integrator program. This program is an integrated role between Northrup Grumman and Bell. We are working together to streamline deployment of these type of capabilities to our fleet by utilizing methodologies of model-based systems engineering and AGILE. We're working in a very close partnership with our program office, Jason Forth and team, to understand how we can deploy these capabilities quickly and swiftly, and as well as have some high integrity of the quality of work products that we transition from systems engineering to software to test to finally for a certification and deployment to the fleet. We are looking at investigating contracting strategies because this is more or less us delivering digital work products to our customer. We're looking at how we can transform those strategies right now into informing and employing our teams to be more productive and supportive of that, especially in this new realm of going digital. We're developing many capabilities for this platform, and we're doing it in an incremental basis. We're looking at any type of opportunities from the obsolescence of our parts that are on this platform, so we can infuse not only new software upgrades for the current platform components, but also if any hardware components are obsolescence, we will look at infusing those capabilities in so we can bring that capability to the fleet as all these technology advances, not only the methodology of going digital, but also in the sense of our technologies. As mentioned before, some of the big drivers and objectives for this program is the speed to fleet. What we're able to do is integrate a cross-team of SMEs as well from model-based systems engineering and AGILE together so we can understand what is our top 10 hit list. We were working with the warfighter very early on to understand what those top 10 capabilities we need to deploy out to the fleet very, very quickly. So we had to bring a team together of not only the warfighters that are out there now, but also the government point of contacts and SMEs that were from this as-is product baseline is already deployed. We needed their key expertise to understand how we can upgrade, modernize the current platform components on here. The quick reaction, the flexibility of our team is something that is very interesting. We work very closely with them during all of our product increment planning to understand if there is some new need, that is some change request that came out into the field because our warfighter is requesting that need right away, we can also place that capability onto our roadmap if we have time and if we are able to. So one of the key things is to be flexible. Even though we have a plan moving forward with our capability deployment, a new change request that comes from the fleet, we can bring that and infuse that in right away. Also interoperability. Like I mentioned before, the new technologies that we're bringing in to upgrade our current components that are on the platform. We're looking not only within Mission Systems, but at Aerospace Systems as well to bring in that technical knowledge of what they've been doing on other platforms. And it's great that I've been able to work across all sectors at Northrop Grumman to bring this knowledge into this team to talk about interoperability that we definitely need. So as mentioned before, some of our very, very core goals here. We're looking at enabling this planning and management not only of the avionics side, but also of the mission system components that are on this platform. It comes not only from Northrop Grumman, but also from Bell Helicopter. We're looking at this from not only a systems to systems perspective that NavAir has been so wonderfully creating for us to understand what those mission use cases are, but then bringing together the suppliers who have been maintaining this as fielded system to understand their system specification at the platform level. Not just the mission components, the avionics components that live inside that platform. So working together as a joint working group has been very beneficial for us. We're looking at tools to optimize and effectively and rapidly deliver these capabilities. As such, model-based and agile applications that are out there today are very quick for effective execution of work products for an agile development process. We're looking also at yearly software releases to the fleet. Hopefully at the end of this year, we'll be having another presentation of this to talk about what our success was to the fleet, enabling these methodologies here. We're looking at continuous integration as well. Anything that comes from other sectors or other suppliers that are coming in, we're trying to infuse their methodologies into ours as well. It is not just a Northrop Grumman, it is Northrop Grumman, NavAir suppliers working together to infuse whatever continuous integration opportunities that we have for this platform. We are also looking at better forecasting of those capabilities. Agile brings us that forecasting to understand where we will be in the future from the new change requests that are coming in and how that will affect our planning for the future and release to the platform and to our fleet. So we're supporting this warfighter as much as we can with deployment of those capabilities, and we want to thank you as well to NavAir for supporting us with that. So now Jason's going to speak to the Navy Challenge.
Thank you, Tamara. So the Navy Challenge right now, as Tamara mentioned, and one of the core goals of Northrop's portion of the LTI program is speed to the fleet. And that's directly aligned to the challenge that the Navy faces. Along the top portion here, we see what nation-state competition has been able to do in comparison to what the Navy is at the bottom. And so you see a lot of these deadlines, a lot of these milestones moving into the left because for whatever they're doing, they're able to pull things in and move a lot faster. Whereas the Navy, in contrast, is moving a lot slower, and everything's moving to the right on the schedule. So we need to increase this in some way, and LTI is a perfect example of how a program is enabling that to happen. The NavAir response right now, again, as Tamara mentioned, the commander's intent remains unchanged. Increase the speed and new capabilities to the fleet. Okay, we have to increase our readiness. We have to support our warfighter much better than we currently are. The strategic initiatives which focus on speed here are through capabilities-based acquisition. So again, the rapid delivery of integrated capabilities so that we can support everything that the warfighter needs to do. The sustainment vision, where we're proactive, we're integrated sustainment operations. The digital business operations piece of this. All of these things come together to help support the commander's intent. Now, all of this is underpinned by what you're going to see through the rest of this presentation, where we're accelerating these delivery timelines of full integrated capabilities, which are designed, they're developed, they're managed, and sustained through a digital thread or a model-based digital environment. So I'll talk to you a little bit right now about how the SE transformation or the SET initiative here at NavAir is going forward and helping enabling the commander's intent. Capabilities-based acquisition here, so what we're doing to outpace the threat. So again, up at the top left of the slide, we've got the integrated warfare analysis, and that's going to feed down into the next step in the process of developing these system of systems models that Tamara mentioned are so key at their level of development. From the system of systems model, that then incorporates not just the ConEMPs or the ConOps and the right size CDDs and things of that nature, but then it feeds into the next layer of the model, the system portion, which is really the center of everything, as we'll see through other portions of this presentation. And the system model employs a language like SysML or like UML to enable and show how the system fulfills the what being described at the system of system level. Downstream from the system model, we have enabling capabilities-based test and evaluation. That's really that next link. It's our transition from what we do in core systems engineering over to the test community to make sure that what we've produced there, and we're bringing the testers in a lot earlier in our process than we've normally done. This ultimately goes down to live virtual constructive-based training or LVC-based training, and that maximizes the fleet proficiency a lot better than what we've currently done, where we just create a whole bunch of training manuals that may or may not get read or implemented as intended. This is how the SET framework is structured right now. Over on the left portion, we have the SET research team. This is less organic to NAVAIR per se. This is actually our interface point with Dr. Mark Blackburn through the Stevens Institute of Technology, who leads the Systems Engineering Research Consortium, or the CERC. And so Dr. Blackburn comes in, he's an integrated part and works closely with our team, but it's mainly the interface point to the CERC. The remaining 5 areas of focus for what we're doing here within the team are shown here on the slide. And so where I fit in, as I mentioned earlier, I'm an infusion and pilot lead for multiple programs here at NAVAIR. H1LTI is one of those. So I fit under SET Enterprise Deployment under the infusion and pilot effort. I also do a little bit of work with the acquisition system reference model that you see listed under the integrated modeling environment team. System model as an integration framework, as we mentioned earlier and kind of set up to this slide, is really where the system model is just a piece of the overall puzzle. There are many other competency-specific and discipline-specific models that have to interface with the system model and provide data to and extract data from the system model. As you see over on the left, external requirements, system documentation and specifications. The system documentation is actually something that we can pull out of the system model in our longer view of what we're doing, where there's a two-way road with the external requirements into these things. On the right portion, it talks about the analysis needs and the performance estimates that go back and forth from specific analysis models like fluid dynamics and things of that nature that come out. But the system model flows down, it's an interconnected piece, and it's the glue that holds everything together in the digital thread. And now Tamara will talk a little bit about our partnership.
Thank you, Jason. Our partnership with NAVAIR and Northrup Grumman and Bell and our suppliers. What we're doing is trying to transform the DoD digital transformation strategy by infusing some principles and methodologies for model-based systems engineering here in this program. What we're able to do is utilize that strategy from DoD and also the NAVAIR framework that Jason just presented. From there, it was driving us to create our own alignment of how we're going to execute model-based systems engineering on this program. Our value, of course, is to improve first-time quality. The first-time quality of our work products, our digital work products that are going to traverse between disciplines, from systems to software to test. So from there, we're also going to look at common processes. We're trying to infuse here not only the standard processes from 15288 as our basis as a starting point, but also how we can be more model-based with our processes to give those kind of guidebooks of how to do your job while you're doing your job. That is something very key that we brought onto this program. Jason and I have really infused that principle about trying to understand how you do your job while you're doing it.
And that's a really important part for us too, is that NAVAIR with the SET initiative has a lot of different things going on, and honestly we're a little understaffed at this point. One of the things that Northrop has actually been able to help us do with our partnership is they've been leading us in terms of those style guides and helping us so that we can help use those style guides as a basis for model-based data item description documents.
So also, what is the value of Agile? What we've realized is that our initial teams weren't actually inclusive of all of the government SMEs and our suppliers. We eventually started incorporating all those SMEs and government participants into our sprint teams. We started realizing that during our reviews, having them as a key contributor and understanding how we were progressing forward and seeing how the sausage was being made was very, very key to understanding the value of those work products. Agile gave us that insight and ability to showcase our work products while being made. And then we could understand if those capabilities that we talked about with the warfighter were being met. So with Agile for us, we were doing regularly delivery and demonstration at an incremental value whenever we had a capability that was ready to be demonstrated to the team, whether it was through a demonstration or through a test. And it was model-based, systems engineering, to model-based software, to code, to a test bench, to actually showcase that capability can be deployed to the fleet very quickly. We did very detailed capability to user stories. We have templates that we gave to our teams to understand how to associate acceptance criteria to model-based products. That is very key. You can associate that understanding of how model-based work products can be agile-based in that type of methodology. So we had that as understanding how to task our teams. We had templates in there so all of our product owners could take those templates and execute and bring those in. We also were working with about how do we understand defects, because now in a model-based realm, it is very data-centric. So we're putting in some constraints and templates as well to understand how we can measure those defects across the capability when we deploy it to the fleet. Also, this trusted partnership that NavAir and Northrop and Bell and our suppliers have to start trusting each other when we do work on this and deploy it together. It is a trusted relationship. We're delivering what we promise for every increment, and we're ensuring that we are agreeing to what is a definition of done in our acceptance criteria. So we are very well aware of all of this criteria that we place up front so we can move forward and be successful together. This is an integrated team, as I said, and we're deploying these capabilities within a year to 2 years. And now Jason's going to talk about how that's building it with an MBSE and Agile framework.
Thank you, Tamara. So this slide here overlays the entire elements or phases that SET is executing here. So you see element 1 up in the top left going down through all the way to element 4. Where we're currently living on the LTI program, like I said earlier on the integration slide, is here at the element 2 level, where that's really where we're working the system model portion. We're really translating customer and higher level capability need into something that materializes. And as the program continues executing, we'll be going throughout the remaining portions of the elements of what SET is identified here. And so here again, this is a little bit more of an expanded view of one of the slides that we had earlier in terms of the integrated modeling environment, and really, again, driving home that point of it being an integration framework and all the different pieces that are going on in here. We have a series of reference models that NavAir is currently developing within the initiative, process models, knowledge models, libraries, scripts, and plugins, all that are in support of the main system model at the center of this. And again, we see how the capability needs are infused, and then how we generate things out in terms of business process and the document generation and the VTL that are being used within the integrated modeling environment. And Tamara's going to talk about modeling process and the approach file model-based.
Thank you, Jason. One of the key things, as I mentioned earlier, about quality of our work products and how to understand and also give that guidance to the team members on not only what are your tasks, but how do you execute your tasks now that you're in a model-based realm, whether it's the applications that you're using, a new language, a new framework. How do we actually help guide? Because we don't want a team to just go off and just start modeling these type of aspects of a program. We want to help support them. There is a standard out there, right here, as you mentioned, the Software Systems Process Engineering Meta Model called SPEM 2.0. What we utilize this for is to manage not only the libraries of reusable method content. So within the method content is trying to understand your role in the program, your responsibility on the program, and the tasks, and those type of tasks and how they're flowed to each other, as well as when those tasks are executed, what are the type of work products that you should be developing as you go through in an agile base in all of our sprints. So SPEM was able to provide them a template of here is your flow of your every day in the life of an engineer on this program. So when they would execute a user story for creating a certain work product onto the program, they also had this guidance too, so they understand their step-by-step what they needed to do. That's different than process. Process tells you the what of your tasks. This is the approach. How do you do every day? Taking those tasks and making it something tactical and tangible for us. So the pillars of model-based systems engineering for this program. I think Jason and I really thought a lot about what were the pillars we had to provide to the team for them to be successful. It wasn't just here's an application, here's a methodology and framework, and go forth and conquer, right, Jason Forth?
That's right. I mean, ultimately, all of these different pieces had to come together in the perfect way in order for this to be a success, essentially. And so that's what we've achieved here. We've got a partner on the contractor side that's willing and able to do everything that we're trying to do within the NavAir initiatives, and we're able to work directly with them, and it's been a very positive relationship because of all the things that they've set up. Again, can't emphasize enough the different pieces that all had to come together for this.
Yeah, we had to really enable the team. So Jason's team and us, when we looked at the contract that we had and we had to deliver specifications, we said, how can we make it all model-based specifications? Whether it's a plan, the technical baseline, the software, our integration for our test architecture, how can we do this? We saw that there was an opportunity here with having this partnership with NavAir and Northrup Grumman to say these are the main pillars that we can place on this contract and build together. And then NavAir can take this and utilize it in their set arena, as well as others. So here, as I mentioned before, the process, we looked at 15288, and so we were modeling 15288 in here. So that can be actually given to anyone so they can utilize it. Not our own command media, but we wanted to make this public and accessible to all. As well as the method approach, that is what we use with SPEM 2.0. How does that inform everyone to do, how do they do their job? Also style guides, just like in software, systems engineering needs style guides. Just because our standard state there are certain relationships, attributes, and objects you require for a certain view of your architecture doesn't mean that is actually the style. The style is what has progressed over decades of learning this methodology, right, Jason?
That's right, and the style guides, as we mentioned earlier, are a very integral piece of this for us because they're helping support providing model-based data item descriptions, which have been lacking as we've engaged in this new era of digital engineering.
And one of the last very things that Mark Blackburn will be very happy about is the product, these meta models. So as you're creating the work products, you have your guidance, you have your styles. I don't know what the impacts are to software, to test, to cybersecurity, to system safety, to reliability. So meta models give you the overarching understanding of your roadmap. How, when I create a certain view, will this impact the next discipline? Does the discipline value what I'm creating in systems engineering? And can they take that into the next stage? That is one of the biggest key things here, and also can help support knowledge models moving forward. Machine learning can be placed against this, so we understand that we have a common language across our suppliers, Northrop Grumman, Bell, and NavAir, that we can now come up with all of our views together, and we can interchange these models easier together and integrate them. Right, Jason?
That's right. So with the intersection of methods in the workforce, so this slide really gets at how these different elements and how the different initiatives within the SET initiative are overlaid in Northrop Grumman's framework. So you see along here the workforce and culture overlay of all the different things that are overlaid in the pyramid of what Northrop Grumman has really done. So everything from recruiting all the way up to initial training, all are mapped in where what Northrop has done, and maybe Tamara, if you can say a few words about that a little bit more.
Sure.
About how your pyramid works, because the new mentors and coaches have definitely been a huge foundation to everything that you've done. Mm-hmm. But I think a lot of the other things have really accelerated the success of the team.
I think it's because of you, Jason, and your team. But they were so very supportive when we first started this program. We, at Mission Systems, we brought our sites together from the East Coast to the West Coast. We came out to the West Coast to help support a team understand what are the current languages out there and the frameworks and the methodologies from systems engineering. From that, we created these style guides and these approach diagrams, as I mentioned before. These help guided the team to develop a system and subsystem model, as Jason mentioned, but we also started creating workshops. These workshops were actually developing those work products and aligning with the approach diagrams, the style guides, and the meta models we had to put in place. Don't get me wrong, it will take some time to get a team stood up, and you will need an MBSE and Agile team to do this about 2 months before you start executing Agile. So you have something in place before a team starts executing. But once you have this team infused together, you can then start having coaches, and you can start infusing MBSE chief architects, Agile architects onto each sprint team, because they will need guidance as they go through. It is not just a once and done and let it go. We continue to help them, right?
Exactly, and that's one of the major successes on the program at this stage of the game. We're a year in, and the entire engineering staff at Northrup Grumman is executing all of their engineering work in the models. And that's a huge step, and it's a credit to what the leadership has stepped in and done on the program. And like Tamara said, it took us about, I don't know, somewhere between 2 and 3 months to actually get that stood up and the process flow working very well. And now it's a well-oiled machine, and we're striving to continue that momentum forward. Yep. And so a model-based pattern for agility here. So we've got the MBSE framework that we've got along here, and that crosses over into our meta model boundaries. So we've got a mix of different things going on here. I'd like to talk about on this particular point where there are 3 elements to what we do when we're executing our model-based systems engineering approach here, is that we have a language, we have a profile, and we have a framework. And so the early on decisions were that the language at the base is just going to be SysML, and that's what we've decided to use across the command at this stage of the game. It's what Northrop Grumman has been using since the beginning. The only differences were a little bit initially with the differences between the profiles. So initially NavAir was, and still is, using the unified profile for DODAF and MODAF, or UPDM, in version 2.0. And so at the operational level, as the capability model and the operational views of what we're doing for H1 have come together, that's what we've been using as the main profile. And that profile allows us to translate the base language into the framework that we're considering the viable piece of this, which is DODAF. At the Northrop level, and we haven't run into major integration snags at this point, knock on wood, but Northrop Grumman, starting at their system level portion of the model, they've decided that they're going to use UAFP, or Unified Architecture Framework Profile. So there's the Unified Architecture Framework, and that's the actual framework, and then there's the profile that enables that framework. So that's what Northrop Grumman is doing, and all of what Northrop is doing is very, very cutting edge, and we all know that contractors always outpace the government a little bit, so that I think is part of the reason. As we continue through at the contractor level, the important piece about using SysML as the base language here is that SysML can be used from soup to nuts, top to bottom. And so there will come a point where we will break ties with SysML, probably at the software level of the model, where we might go pure unified modeling language because it's better suited for software. Again, using the right language for the right need. But we do have that ability, and again, the crossover from SysML to UML is very, very straightforward because SysML currently is based on UML. And so Tamara's going to talk about digital artifact creation.
Thank you. So now let's talk a little bit about how we've structured our models and how we've working across these digital views within our models that we have between NavAir and Northrop Grumman and our suppliers, and of course working with Bell. As you can see over here, the operational model is given to us by NavAir counterparts, Jason Forth and team. We then here on the bottom hand corner here, the system and subsystem model, as you see. All of this, we bring in the NavAir model into one repository. This is where our authoritative source of truth lives. So we can actually do traceability between the operational domain and our system and subsystem modeling domain. As you can see here, what we're trying to understand is that within these models, we're going to have different levels of architectures. And those levels of architectures have to give some digital views for a concern. So if our government counterpart comes in like Jason and has a certain perspective that they would like to see, we can actually pull from this integrated set of models from the operational domain and capability domain all the way to the system and subsystem modeling domain to see the traceability and impacts all the way down to our design. This is very, very key for us because we have to have enabling elements to be able to do this. And those enabling elements that we've talked about before is that meta model, as you see there, because we need to understand a 2B functional baseline. We cannot create a 2B functional baseline unless we understand how the operational domain and that warfighter really has a day in the life. So we need to include not only the operational side, but also the system functional and subsystem functional domains as well into that 2B functional baseline. So therefore, those enabling elements, like I said, the meta models that we created is helping structure and understanding now across the models that are delivered from NavAir to Northrop Grumman, and then creating that together as an integrated model suite. These style guides and structural modeling approach help guide us in understanding how those architectures are going to be built, not only across NavAir, but also Northrop Grumman. We utilize those same style guides moving forward. We've also created profiles, which is very key for contracts, right? To understand how we are going to deliver, approve for these type of digital artifacts moving forward in the contracts process, because no longer is it just a system and subsystem design description document, it is actually a model. So how do we place approvals against the different views, the different digital views within this model? We've incorporated profiles to understand what the classification levels are within each of these views, as well as the policy against them, as well as how we're going to deliver them to contracts to get them fully released into a configuration managed state. Let's talk about plans a little bit, because this has been a hot topic on this program from the very, very beginning. And Jason was the key component to allowing us to make this all model-based with our plans.
Well, and the reason that it's all model-based with our plans is because that's the NavAir vision, is that everything as much as possible is in the model. And so that's what Northrop has really been able to show through their deliveries of the model each time, is that as they've gone through, they've created the digital views of a plan like a system safety program plan or a systems engineering methodology and architecture plan. Or their CMAP is what's come together and really come together very well in the model. It's what's being delivered. It's what our stakeholders on the government side are actually looking at. They're actually looking at models. They're not looking at paper-based documents anymore. And that's a very key element to making this model-based digital thread idea a success for the program.
Yes, and as you mentioned before, all these plans, as you see down here, whether it's a configuration management plan, even your program management plan, your software development plan, this was a culture thing for us to move away from 200 pages of paper-based plans and saying that you can create flows of those type of tasks within each of those plans, only a few set of those diagrams that have descriptions. It removes so much of additional work, and now it's consistent across not only our technical baseline that we're delivering, but also now against our guidance and approaches. So now within the team, you can go to 2 or 3 diagrams and know exactly, as a software engineer, these are my tasks based on my standards, and then we give them the guidance on how to do that on the program. This has been very, very new to the team members because they're so used to developing word-based plans and delivering them. This is something new as well for contracts, because contracts isn't used to getting a model for a plan. We still need to do contract letter cover pages to help support their understanding of how these digital products can be delivered to the customer.
And so for the end state development here, and what we're looking at for process and methods on the technical domain side is, as we alluded to in the prior slide, the procedurals and the discrete setter events, they're going away. And that's part of the digital transition, is that at any given time, someone can look at the model and understand the complete picture of what the current state of the program is, what the current state of the design is, what the current state of plans are, anything that they want to know about the program or the engineering portion of the program, they should be able to get from the model. And so there's competencies that use all of these models that they define, they simulate, they validate and verify all the compliance and interfaces that are being put into the model. Government and industry both are employing the model data as the alternative procedurals, as we talked about. The near continuous stakeholder awareness is a major piece of this. We're standing up an entire integrated digital environment for the team to collaborate in. And then it all results in integrated model-based verification and validation. And so in terms of the pros and cons that we've seen from the effort, unfortunately the cons list outweighs the pros, but we're going to start with the pros because we like to start positive. So the one very good thing that we've seen from this effort is that model-based systems engineering exposing risks on a per sprint basis, and that allows the overall development team to adjust real time as opposed to waiting weeks or potentially months on end for a design defect to creep in and not understand what the nature of it is until it's too late. They're able to see that in the model much sooner, and so they're able to react to it, and they add it into the backlog under the Agile process. Another good thing about what we've seen with this is that systems engineering and the other core engineering disciplines, they're being made more aware, more comprehensively, earlier in the phase of the program that we're in right now than when they might otherwise be brought in. Say a safety engineer would normally be brought in 6 to 8 months down the line of a program starting. They've been involved in the beginning of this, and so they've been able to see some of the good, the bad, and the ugly with this. Okay. Model-based, for the cons side of this, unfortunately the sprint team that's dedicated to model-based systems engineering, that's responsible for managing the health and the overall model health and system are getting overwhelmed. There's larger portions of the deployment team right now that are working the engineering side, and they're putting all of it into the model, but the MBSE team is quickly getting overwhelmed because there's only so many hands to go around at this point.
Yeah, and that's one of the key things that Jason and I are really trying to do out in industry and academia, is trying to bring awareness that MBSE is actually a true skill set within systems engineering right now, because of the languages and the frameworks to understand how to execute this over different programs, different sizes. It is very key to have that skill set moving forward if we're moving into a digital realm, just not only in systems engineering, but across all the disciplines. So for us, as he stated before, one of the cons is we didn't have enough experts, even from NavAir to Northrop to Bell to our suppliers. So that is one key thing for any program. A lesson learned there is really do try to bring that skill set up, mentorship of people that are very interested in this skill set of MBSE, and then try to grow them and lead them on these programs, because that's how you're going to gain the next magnet of talent to help execute these in the future, because this is going to come down in a lot of our RFPs, and we've been seeing that recently.
Exactly. So one of the other major sticking points that I've seen in the execution over the past year of the program, unfortunately, is that earned value management. Mm-hmm. The size and the dollar value are governing Northrop's internal processes where they need to collect earned value metrics. And unfortunately, the constant back and forth between the management side and the engineering side is somewhat inhibiting the organic development of the model. The sprint period of 2 weeks, one of the other cons, is somewhat short. It inhibits a little bit of the startup of the system side of the model, because what Northrop has had to do to adjust to this is they've actually had to go on a full increment basis to produce just a few of the system level threads to be able to help guide the lower level portions of what are being developed on the sprints. Mm-hmm. Cross-sprint team awareness of approaches and style guides. We've seen, and again, this goes back to a lot of the early lessons learned where the team was coming up to speed and not really understanding the approach and not understanding what the style guide said or know where to go to look for the style guide. So it required a lot of extra education across from the MBSE team to the engineering side to make sure that they knew where to go to look for what they needed to be successful in the model.
Yeah, that's one of the key things. If you're going to have a multitude of sprint teams that are maybe 7 to 10 people per sprint team, and you do initially start, like I said, in the first 2 to 3 months to have a dedicated MBSE and Agile team to build up all these methodologies, these plans, these processes, style guides, and meta models, you will have teams executing in parallel the architecture as such. So one of the things we notice is that type of lack of cross-sprint team awareness. But what we infused then to solve that was more of navigation panes and more of communication of lunch and learns of this is the new thing that we've deployed out for you. These are the dependencies of your user stories for the products that we have to help guide you. But of course, just as we're always running in the very beginning, that's one of the things we learned is do take your time in the very beginning of a program to get this stood up well before other sprint teams start executing what now is to-be capabilities to be placed onto the platform, and any as-is functionality that wasn't model-based before, you can start infusing that in. So that's one of the key lessons.
And that's actually a good roll into the last con that we observed with the initial execution of this, is that H1 is an existing platform, and so one would think that as an existing platform we have an allocated baseline. Unfortunately, coming into the program we did not have an allocated baseline to work with, and so that meant that we had to go not only create what we wanted the program to grow to, but we also had to infuse into the model the as-is aspects of the program.
And that's very key, because at one point in time at t = 0, you have a physical system that's already deployed and it has an architecture and its design. And at the same t = 0, you'll have a 2B system as well, a 2B functional design of that system. So you have to understand how the infusion of both an as-is and 2B can help align and bring together new capabilities onto the fleet. And that's one of the key things that we had to infuse, is these teams had to not only think about what is the future, but what is the history. And you need to bring those two together, so when you do modernization programs, it's not always forward thinking of some new hardware, software, firmware onto the platform, but also the history of how it got there and what currently products are still going to exist on that platform because it is currently deployed.
And so this concludes the presentation and is normally the point where we would open for questions. Because this is a video, We're going to go ahead and set this up on a particular link. We'll have blog and Q&A posts for any questions that we receive as part of this. We do hope that this was helpful and that you got out of it what you wanted to, but please feel free as this goes live to ask other questions, and Mrs. Hambrick and I will do our best to answer them as time allows.
We will. Thank you.